So test grades overall were really good. I had some really high grades, a whole lot of really high grades. I do have tutorials right after school today. The only thing that is open to be requizzed on is molar mass. And that's the only quiz that's open right now, and that does go until next Tuesday. I had a couple of people that were not here yesterday. Who wasn't here yesterday? Okay. So y'all, if y'all can come in, and who was the other one that wasn't here yesterday? Okay, you weren't here. So if y'all can come in right after school, then you can go ahead and take the test. If not, then it'll have to be Monday after school. Not Monday. Well, yeah, we can do it. Oh my God, do Tuesday after school. Okay. And so what we're going to do today is we're going to kind of just do a big overview of periodic table. A lot of it will be stuff y'all already know. And you do have a quiz over that tomorrow, 15 multiple choice. And you'll have about 10 minutes on that quiz. So be sure that you study for that. If you have trouble getting through it in 10 minutes, then you didn't study enough.
Which one's the molar mass one? Is that the one with the four questions?
Mm-hmm. Yes, it is. All right, I'm going to do attendance real quick, and then we will move on. Maybe I'm going to do attendance if I can remember. All right, so what do y'all remember? Who remembers something on the periodic table? Nobody remembers anything?
I do.
What you remember?
It's separated into groups and periods.
It's separated into groups, right, this way, and then periods across. What else?
Ain't the ones all on the far right, yes?
On the far right, mainly your gases, non-metals for sure. But you're right, the majority of them are gases. On this periodic table, anything that's red is a gas at room temperature. Anything that's black is solid at room temperature. And then there's two that are blue, and that's because they're liquids at room temperature. The white are man-made. So I guess there was, I don't know, scientists that didn't have anything else to do. I don't know. What else do y'all remember? I don't remember any names of any of the groups.
Noble gases.
Yes, ma'am.
Groups 3 through 12 are transition metals.
Perfect. 3 through 12 are transition metals. Metalloids along the little stair step. So remember that stair step, and I think on your periodic table it's also dark. It separates the metals, which make up the majority of the periodic table, into just that little group of non-metals. Not all non-metals are gases, but the majority of them are. And then along that stair step, there's some transition metals, and we'll identify those in a minute. And then they're arranged according to atomic number.
I think that's mine from Michelle Study.
For Michelle Stetter, that's usually when I start teaching this, I hear a lot about Michelle Stetter. Y'all remember a lot from her class. So that's a good thing. Remember, what does she call group 17?
Y'all something super like
Gangsters? Do y'all know, remember why she called them gangsters? Because they're very reactive. So they're very reactive. So yeah. That's that. All right. Did Michelle start? All righty. So let's do our notes. Possibly, maybe. All right. So periodic table is the most useful tool for scientists. This a little bit before y'all have a place to fill in. I mean, some of this is just a little introduction. Because not only does it have all the information about the elements, but because of the way that it is arranged, it also lines up elements that have similar properties also. So before the periodic table, there were about 70 elements. If you look at the top 1850, there were already about 70 elements that were discovered, but they weren't arranged in anything. So it's kind of like if you go in your closet and you have a messy closet and all of your clothes are crammed together, maybe you forget if you've worn something or not. It's not very organized. Same thing with those when there wasn't any organization. So it was really difficult to find information and then to share that information among scientists. So Dmitri Mendeleev was considered the father of the periodic table, and he arranged his in rows according to atomic weight. So weight is your first blank. So he put elements in columns, which eventually became called groups by the way that they reacted. So if they had similar properties, he wanted them to be in the same group, and that still holds true today. There were some problems with his periodic table. When he lined everything up according to atomic weight, there were some blanks or places where he thought elements would eventually be discovered, and so he was right. They did eventually become discovered or were eventually discovered. And then also, since he wanted them to be lined up according to similar properties, he had to break that pattern of atomic weight. It didn't really work out or hold true in the long run. So about 20 years later, Mosley came along, Henry Mosley, and he came up with the basis for the current periodic table, which is arranging things according to atomic number, which we know is the number of protons. So that was a new periodic table, and that is the one that is used today. So he still wanted the elements with similar properties to be in the same group. So he decided, once he got everything and started laying them out and arranged them according to atomic number, he decided there needed to be, he may have originally started with 17 and then added the 18, but he decided how many groups there needed to be so he could get the elements with similar properties within the same group. And that's called the periodic law. That physical and chemical properties of the elements are periodic functions of their atomic number. So their elements are in order according to their atomic number, and when that happens, they line up to have similar properties within a group. The horizontal rows, so going across, those are called your periods, and then the vertical columns are called your groups. There is more similar properties in a group. So we'll talk about periods whenever we talk about a periodic trend, but if you're looking for similarities, you really should be looking at for elements in the same group, not so much in the same period. I can't remember if there's something else on this one or not. So periodicity is the similarities of the elements in the same group can be explained by their electron configuration around the nucleus, which is what our next unit will go. And elements in the same group have the same number of valence electrons. I'm going to be using valence electrons, so you may want to write it out one time for yourself that VE is valence electrons. And because of their similarity in the number of valence electrons, that really leads to similar properties in what kind of compounds they're going to form. So this goes in that line that is 1, and this goes in that line that's 2, where you have 1 and then a bunch. Elements in the same group have similar chemical properties, and this was done on purpose. It wasn't just by accident. This was Mendeleev that took the time to arrange that and decide how many periods and how many groups there were needed. And like I said, it's because they have the same number of valence electrons and they form the same number of ions, or same kinds of ions. And the reason they form the same kinds of ions is because they have the same number of valence electrons. If everything in group 1 only has 1 valence electron, then that means everything in group 1 wants to get rid of that 1 valence electron that's making it unstable. So everything in group 1 is going to form a +1 ion. Columns can also be grouped into families. A family may be just one column, or it may be several groups put together. But families have names rather than numbers. So 1 through 18 along the top, those are group numbers. Those are not family numbers. Okay, couple things at the top. If you look at the top of their notes, there's nothing to fill in. But we're going to talk about one of those. Hydrogen is in group 1. At the top of group 1, it's an oddball. It's not an alkaline metal, but it's in group 1 because it only has 1 valence electron. It is very reactive, and it's one of our diatomics. It was what called the Hindenburg explosion of the Hindenburg blimp because it was so reactive. And then helium, which is over there, group 18, it is a noble gas. It is non-reactive, but unlike the rest of the noble gases, which have 8 valence electrons, it only has 2, but it is stable with just 2 valence electrons. And it can definitely exist by itself on its own. All right, starting with group 1, the alkaline metals. So first column on the periodic table, but excluding hydrogen. Very reactive metals, so they're always combined with something in nature. They're really soft. They're not like what we think of as typical metals like aluminum or gold or silver. Soft, kind of flaky metals. They will react violently with water and with air. They end on the NS1 configuration, which has to do with electron configuration. The S block is made up of group 1 and 2. So groups 1 and 2 make up what's called the S block. Everything in group 1 has 1 valence electron, including hydrogen. Group 1 and 2 have as many valence electrons as their group number. 13 through 18, does anybody remember what you had to do to those group numbers to figure out how many valence electrons you had? Subtract 10, right? So like 13 minus 10 would give me 3 valence electrons. Transition metals, they don't follow a set pattern. They can be kind of wishy-washy. So we don't deal a whole lot with those in Chem 1. All right, then we went to our group 2, our alkaline earth metals. So this is going to be our second column. So that means 2 valence electrons. S block, it has to do with electron configuration, which will be what we move to our next unit, how the electrons are arranged. So this is still part of the S block. They're still very reactive. They're not found by themselves in nature. But they're not quite as reactive as a group 1, so they're going to be a little bit stronger, harder, denser. They still will react with water. And they do have the 2 valence electrons. With your metals, so this is group 1 and 2, and also your transition metals, but especially group 1 and 2, the reactivity increases down the group. So that means if I know group 1 are my most reactive metals, if I come all the way to the bottom to francium number 87, that is my most reactive metal in the whole periodic table. Very dangerous metal. Not anything that we would have here in lab or at school. Oh, very reactive. It sounds like fun. Maybe a little bit more fun than we need to have at high school, huh? I mean, we got such a big issue when we just try to use a gas, so probably be really worse if we try to use francium. All right. So then we go to our transition metals, like somebody pointed out, those ones in the middle. So these have our classic metallic properties, which we'll talk about in a minute. These are considered to be on the D block. These are what we think of as metals. Copper, silver, gold, platinum, those kind of things. And these have variable valence electrons. So your valence electrons differ. It's not like our other groups where we can figure out how many they have. And sometimes some of them will have 2 valence electrons, and sometimes that same element may have 3 valence electrons. So like I said, we don't work a whole lot with these. We'll deal with them when we're working with compounds. So talking about your typical metallic properties, I know y'all have heard these before because I've heard y'all use the words malleability. That means it can be hammered into sheets, you know, without breaking. It's not brittle. Ductility, it can be pulled into a wire like copper wiring. Luster, they're shiny. That's why we like them for jewelry. And then they're good conductors, conduct electricity and would conduct the heat or cold. All right. Then we're going to go, this should say groups 13 through 18. So these are going to be our P blocks. So starting over there on the other side of the periodic table. So kind of moving over to our non-metals. So within this P block, we have still a few metals left. We have our transition metals, which you might want to jot down. And then we start having non-metals. So our transition metals are the ones in purple. And they're on that stair step. B for boron, Si, As, Se, Sb, antimony, and Te. So our metalloids, because they're in the middle, they have properties of both metals and non-metals. They are conductors, but just semiconductors, not as good as our true metals would be.
What is it? You said semi?
Semiconductors, sorry. S-I-M-I and then dash C-O-N-D-U-C-T-O-R-S. So we said to get our valence electrons here, we're going to take our group number and subtract 10. The one little exception would be helium because it's in group 18, but it only has 2 valence electrons. It's stable with just 2. For our non-metals, reactivity increases up a group. So we know our halogens are our most reactive nonmetals, so that means fluorine would be our most reactive of all. And these are all considered P block, which is also going to have to do with our electron configuration and how the electrons feel. Okay. All right, so these different little families are not on your notes. You may want to just kind of maybe jot them down on the end here. As far as what they're called, group 13, boron family, it starts with boron. Not anything too important about that. It does have aluminum in it that was once considered like a precious metal like gold and silver, but now we think of it as a disposable metal. And so this would have how many valence electrons? 3. Mm-hmm. All right. Next one is carbon family. Y'all don't need to write all of that down. And since it starts with carbon, it kind of makes sense. Group 14, how many valence electrons? 4. Carbon is the basis for an entire branch of chemistry. Does anybody remember what that would be called? What did you learn in biology? Organic, perfect. Organic, all living things have carbon. So organic chemistry is a special chemistry that a lot of people find really hard. They take in college that has all to do with carbon. Carbon compounds, especially in living systems. All right, next one, nitrogen family. So group 15. Nitrogen makes up a lot of the atmosphere. I'm not going to ask you how much of it. But we know living things, if you remember from biology and the nitrogen cycle, that it has to be recycled because nitrogen in the atmosphere usually is not usable for us or plants, and so it has to be fixed. And it would have 5 valence electrons. So when you get to 5, 6, or 7 valence electrons, that's getting closer to 8, which is an octet. So those elements, instead of losing electrons, they want to start gaining. So like anything in the nitrogen family, it would like to gain 3 electrons to get to 8. So these start becoming negative ions. And we'll spend a little bit more time on those. All right, then oxygen is group 16. So the oxygen family are the chalcogens, and I don't know where that name comes from. We know we need oxygen to live. And sulfur is in that group, and I don't know if any of y'all ever been by a sulfur plant or smelled sulfur. It smells like rotten eggs. It stinks. So 6 valence electrons needs 2 more for an octet. So these tend to form -2 ions. All right, now this one is where there's a place where you're group 17. Halogens. So elements in group 17, they're very reactive nonmetals. And like I said, they get more reactive as you go up. So since they're so reactive, they're going to be found combined with other elements. There's many diatomics in this group. I think all but one. So that just shows that they're reactive. They have to be combined with another like element or in a compound. These would have 7 valence electrons. So they only need one more electron to get to their octet. That's what makes them so reactive. They're trying to find that one electron to grab from probably somebody in group 1. All right, noble gases, group 18. So these are very reactive monoatomic gases. So that means they can exist as just one atom. Very unreactive. Did I say reactive? So neon, they're used in blimps. They have a full valence shell, which is called an octet, which is 8 valence electrons. Y'all see that or not? I'll rewrite it up here. Octet, 8 valence electrons. Except for helium, even though it's a group 18, a little exception, but it's still stable. Where's what up, babe?
That section.
This right here,
No, like on here.
under noble gases, group 18 right here. Is that what you mean, or am I still not understanding?
Okay. I don't know. Like,
You want to see it in my notes to see if it helps you? Maybe if I'm not understanding. Does that help? Okay. All right, so the S, so that's group 1 and 2, and then the P block, which are 3 through 18. I'm doing this, are called our representative elements, okay? And those are the main ones that we work with in Chem 1. They kind of follow the rules. Transition metals sometimes don't really like to follow all the rules. So that sometimes goes to a higher level chemistry. All right. Then these 2 pulled out sections, so they don't match up with the other groups. And then if they would have been included in the periodic table, it would have made it huge. But those are considered our F block. Still types of transition metals. The actinides, that's where your radium is. So that's going to have some of our radioactive elements. All right, I'm going to stop recording. I was recording because I'm going to have to leave here in a bit. Next period. And then we're going to watch a little video. And then that's going to be a good place to stop
so it's just tomorrow.
for today. It's 15 multiple choice.